The first one, SDS polyacrylamide gels and Western blotting. The second laboratory teaches people immunoelectron microscopy. And the third one, intracellular signalling as part of cell biology. And the three laboratories were originally created about 5 years ago as embedded units inside a course, molecular and cell biology, that the Open University has presented for the last 5 years. And this goes out on DVD to the students, but for the Open Educational Resource project we have placed the laboratories as self-contained packages so that anybody can download them and use them, and we've provided background material with them. The uses for these resources are initially to teach people how to design experiments, understand experiments and interpret their experiments. We've gone on to use them to train people as to how to use an SDS gel apparatus before they actually get into the laboratory. So we have very little time with our students actually in wet labs, and we do as much as we can before they come into the laboratory to improve their time when they're with us. And finally, for something like the immunoelectron microscopy laboratory, you just cannot let large numbers of undergraduates do that kind of practical, and so it's a real opportunity to let them have a go at this kind of thing and interpret the results from it. So it's solved a number of problems for us. The material is designed initially to be available. We clear the material that we have, the copyright on it, and the things are designed to go out to students for them to be able to use without reference to us, because frequently they don't actually have opportunity to talk to the person who designed the program or to talk to the person who's in the laboratory doing these things. So I think we're at an advantage here. We were designed from scratch, as we always do effectively for distance teaching. It has really three components in it. The introduction just sort of leads you into the ideas of the thing, and then there's a section here which is just describes sections of. I'll just turn the speakers on.
Detection of a protein antigen by a bound antibody. In direct immunocytochemistry, the antibody raised, for example in a rabbit, against the antigen is directly coupled to the gold particles and applied to the surface of a section.
Okay, so the first part of it just describes the theory of the technique, and then in the second part here, and I'm going to expand this to fill the full screen now, we actually show what happens in a laboratory. So there's about 10 or 15 minutes of video here. It starts by showing the sort of research worker here in one of our laboratories actually preparing the cells, and it goes on to show things in the electron microscopy lab, which we can have a look at later. And then in the sort of final part of the thing, in fact the main part as far as the students are concerned, they have to go to a laboratory and answer questions. So on this one here, they're being asked to locate a particular molecule inside a cell, and they have to answer these questions. Where is it located? They have to go to the laboratory. So they click on this button down here, and this takes them to the immunoelectron microscopy laboratory. And then they will say they might treat their cells by dragging and dropping things on here. They will culture their cells for certain amounts of time, so I'm going to culture these both for 30 minutes. So I'll culture the cells. And then having done that, I'm going to treat them with different antibodies, like this, and then I'm going to view the micrographs. The program effectively has an algorithm inside it that can generate up to 4,000 different electron micrographs and decorates them in a variety of ways. So I'm now looking at the cell which has got the immuno gold spots on it, which are effectively in the positions according to how the person has treated the particular cell types. So we've got different micrographs here. You can see the endoplasmic reticulum on this one with the molecules on and so on. So briefly, if we just sort of move that out of the way, you can see, and then once they've done that, they will have answered things. They'll go back and they'll start to answer the questions that come out of this by pressing these sort of tick boxes here. I'm just doing this at random at the moment, and then you check that, and it tells me my answer is incorrect, which is not surprising. I did it more or less at random, but it'll allow me to go to and fro between the laboratory and try these things out. If you did this in a real laboratory, it would take about a fortnight's work, and you just would find it an awful lot of work and very difficult. It isn't unless undergraduate level. We can do it here. The programs here were originally written in C++, and they are very easy to adopt because they can be downloaded as a complete package. They have laboratory manuals with them, they have demonstrations, they have assessment materials and tutor notes and everything that you might want. So you effectively just download the thing, it will unpack, and then you can just run it. Adapting it is more difficult. You would need a programmer with it who had an understanding of the underlying program structure. But particular bits of it can be picked out of the program. So, for example, the video can be picked out per se and just used as it is. That's a useful resource unchanged. And we've also provided all the background reading material from the original course here. And that material has lots of illustrations, lots of text in it, which is all available as an open educational resource. It also is available from OpenLearn from the Open University, so bits of that can be taken apart and adapted as you want to. I think the main advantage for me so far, this is 3 months after the project has completed, is the contacts that I've made. I've been currently engaged in producing a virtual microscope, and I'm producing a virtual ELISA laboratory for other courses. And I've been in touch with a lot of people via the OER project who have got slide sets and things like this, so that we're planning to put in some grant applications and make more material available for other people. So for me, I think it's a good thing that we've let this material go out and hopefully is available and useful for people, but for me it's the contacts that I've made and the possibility of taking things forward for new open educational resources. At the Open University, we've always had an awareness of what we must do to make things available, particularly the clearance of copyrights, which we always do early, and that's, I think, a key thing. The one thing where I have changed my thinking is the particular projects that I've talked about here have been done as self-contained units, so that someone can download them and then they get an immunoelectron microscopy project looking at where molecules move in a particular liver cell. For the ELISA practical, which I'm trying to develop, I'm trying to make a general solution to it along with the programmers, so that anybody who wants to have an ELISA for, say, looking at infectious disease or the production of antibodies or looking at molecules in serum or looking at enzyme damage in liver or something like that, can effectively plug their own material in much more easily so that it will be adaptable.
I'm the manager of the electron microscope facility, and here is a 120 kV electron microscope, a transmission electron microscope. So it has the capability of accelerating electrons at 120 kV. It has a big magnification range from times 50 up to about 250,000 times. It has a digital camera, and you can see that there's an image on the monitor from the digital camera, and the specimen goes in at this point here. The cost of this instrument is about £250,000, so we look after it very carefully, And postgraduate students are permitted to use the instrument 24 hours a day, but we do not have undergraduate students using the instrument. The best way to use this instrument is as an educational resource over the internet, where this can be filmed and used as a virtual research experience.